In the section M.1.7, we're going to apply estimation strategies and rounding rules to real-world problems. What you'll be basically using is the metric system, because that's what you mostly use in the medical studies. One of the first things you want to do when you first start a section is to look at the objectives that are over here on the right-hand side, and go to the very bottom of the first page and look at your little keywords that are here. Once you understand those, then we can actually start looking at these sections. Since we're going to be using the common metric units, we need to know some of the common metric units and their household approximations. Posted in Canvas is this metric units handout. It gives you your basic metric units, a little way of remembering the abbreviations for them. And then also we're going to talk about the metric system of length, which is meters. Your metric system of mass and weight, which is grams. Your metric system of capacity, which is liters, like a 2-liter bottle. And then Celsius, which is the metric system of temperature. Fahrenheit is the English measurement. Celsius is the metric measurement. And these are the formulas that you will be able to use if you're going from Celsius to Fahrenheit, or there's two different formulas for Celsius to Fahrenheit. You will not have to go from Fahrenheit to Celsius on the TEAS test. Once you've studied the metric units, we need to talk about square units, such as square meters. When you're talking about area, which we'll also be talking about in a later section, is measured in square units. Volume is measured in cubic units. And one of the first units of measure you need to understand is that 1 liter contains 1,000 milliliters on 1 cubic centimeter. So the helpful tip is that 1 cubic centimeter is the same as 1 milliliter. And that is used a lot in the medical field. Then on the next page in the TEAS manual is the estimation and rounding. One of the things I want you to go ahead and read this whole paragraph, but the main thing is when you are estimating, you need to decide how close do I need to be to the actual answer. Can I just be in the ballpark and be reasonable? When working a problem, you can estimate your answer to determine if your mathematical procedure is correct before you solve the problem. So in this front-end estimation example here, is when you focus on the first digit of numbers when adding or subtracting and solving a simpler problem. So I'm going to let you read this, but in this particular example, they rounded 3250 to 3000. They rounded 7600 to 7000. The new stove is 985, so they rounded that to about 900, and they used that to make it a whole lot easier to add without using a calculator. Then you need to review how to round decimals. In this particular example here, the number 73.281, we're going to round to the ones place. So remember, the ones place is the first digit on the left-hand side of the decimal point. So we're going to look at, this is the number we're going to round to, but we have to look at the digit that's to the right of that. That's a 2. And for our rule is for 5 or larger, round up. Less than 5, just remove the digits that follow. So this is a 2, this is less than 5, so I'm going to leave this digit the way it is, and then drop everything on this side of the decimal point. So it's a rounding number of 73. So when you're rounding decimals, this is the set of rules. Locate the digit in the place value you're rounding to. Look at the number to the right. If it's greater than or equal to 5, you round up and delete all digits to the right of the given place value. If it's less than 5, delete all digits to the right of the given place value. And this is the little symbol that's used for rounded values. Then we need to learn how to round decimal or round fractions to the ones place. And the rule is if the numerator is greater than or equal to half of the denominator, round up to the next whole number. If the numerator is less than half of the denominator, round down to the existing whole number. And you can see some of the examples right here. You can refer to the handout that's posted in Canvas on rounding fractions. And the rule says if the numerator is greater than or equal to half of the denominator, round up to the next whole number. So you had some examples in your book, so we're going to have a couple of examples right here. 9 over 16. Since 9 is greater than or equal to half of 16, which is 8, we're going to round up. So we round this example up to 1. 11 over 22. 11 is greater than or equal to half of 22, which is 11, so you're going to round up again. An example where we don't round up is 3 over 8. 3 is less than half of 8, which is 4, so you're going to round down to the whole number of 0. If you have a calculator and want to round fractions, and what you could do is take the fraction, enter into your calculator, convert it to a decimal, then round it that way. what you'll be looking for if you change your fraction to a decimal is the decimal point less than 0.5, which means you'll round down, or greater than 1/2 or 0.5, which means you will round up. Once you've read all this section 1.7 and are ready to do your practice problems, you can look into the Canvas, and I have worked out all these problems exactly the way they're written right here, so that you can check your examples answers against the actual answer key. Good luck on this section. Thank you.